our next talk, we're going to talk about things at scale. And I'm super happy to introduce Director Ishu Gupta and then Sandy Shen, who's the Senior Director at Capital One in the pipelines and developer experience area. And the things that are super important here is they have experience at scale, like big scale. And things are different there, and I think there's a ton that can be learned of what's the success and the benefits, and also what are some of the traps and the things to watch out for. So once again, gives me a great honor and pleasure to introduce Ishu and Sandy. Take it away.
Thank you, Mark. Awesome. Yeah, we definitely run things at scale at Capital One. And yeah, I'm sure some of you have heard about our pipeline system as well. So we're going to cover that a little bit. Before we go a bit into details, real quick introduction. I'm Ishu Gupta. I work on the CI/CD pipelines at the company, and I also lead the CI/CD execution platform, which is Jenkins, and its modernization. So I've been with the company for a long time, almost a decade. And yeah, Sandy, you want to talk about
Hey,
this?
good morning, Dallas. I'm Sandy Sen, a proud father and husband. I work on the other side of Ishu Gupta, on the one pipeline side. My focus is on making the releases successful, fast, and more importantly, compliant with all our policies.
Perfect. Thank you, Sandy. Yeah, so like I said, we're going to talk about one pipeline and how we have several of these pipelines, how do we maintain compliance and standards through that. But you know, I'm going to give you a brief history lesson. I promise it's not going to be long, but I think it's important to still share the context on how we got things at Capital One from one pipeline and why they are where they are. And then we're going to talk about how did we do that journey and then our takeaways from that journey. So like I said, a quick history lesson, you know, this is where we were, I think before almost a decade ago, and not just us, but a lot of companies in the industry. This is how the software delivery happened, right? And I'm sure a lot of you probably remember about this process. We had teams for specific purposes, right? We had teams building software, just writing code. There were teams which were just doing, you know, responsible for building your WebLogic domains, Tomcat servers. There will be a network team responsible for setting up your firewalls, you know, and setting up your packet captures. There will be a team which will be just writing your QA test and setting up your QA environment, etc., etc. Each team has its own function, right? Like one team will do their job, toss it over to the wall to the other team and say, hey, I've set up your network now, go ahead and write code, and on and on. So things worked at that time somehow, right? It took sometimes days to weeks to go to production, and it used to be a norm. Obviously, that was not what could work today, and it was way behind its time, right? So we realized that there is more leverage in introducing you build your own model. Basically, we empowered our team to say, hey, we're not going to have 50 teams do help you go to production. We want you to be more empowered and take controls in your own hand. So we asked the team to figure out how to do the builds and deployment, and also do the development by ATDD style, you know, testing driven development. And we also made them, you know, tools to say, hey, you can go ahead and release and host your application in production and be in charge of doing it at scale. You know, that worked very well. You know, we saw that the YBYO, which is you build your own model, empowered our developers, right? It injected a lot of innovation across the board. Teams were figuring out ways to go from dev to production in a compliant manner across the board. And yeah, like a lot of them came up with very innovative ideas. However, that also caused a big problem, right? We had several of these teams building their own pipelines. Now, you know, we are a large company. You can imagine, I would say roughly around 15 to 20 teams would have a dedicated DevOps team helping them write their CI/CD pipelines and go to production. And you know, there would be teams which are just solving the same problem over and over again. People would be sitting few feet away from each other, writing pipeline for their Lambda function to go from dev to production, or maybe, you know, same for Fargate or any other service. And that model created a lot of duplication and a lot of you know, inconsistencies across how do we push software across the board. we made a big decision. Capital One said, okay, instead of doing this across the board, let's think of convergence. But doing the convergence all at once would have been really rough. So we thought, like any other company, we have several lines of businesses. So we made a decision to consolidate these pipelines across different divisions, right? And that model worked pretty well. We started to see the big convergence happening across several divisions, and we picked the best software delivery process across of these decisions and landed on one over each. So although it also standardized our software delivery process across divisions, we still have several of them. We identified 3 key problems with our LOB-based convergence approach. We realized we still have arbitrary uniqueness across those pipelines. We identified that while the teams across these divisions are building tools for their pipeline, they still had a lot of deviance from each other. So for example, one team would be using Chef for configuration management. Some team would be using Ansible. Some team would be using Jenkins. Some team might be using Circle CI. Teams might be running their own Jenkins across different divisions. That was just becoming very, very hard from managing and maintaining software. Also inconsistent standard. There would be teams which would be using Git flow or trunk-based development. There would be teams which are maybe not even a branching strategy. Maybe they are just pushing, everybody is pushing to master. Hopefully that's not the case in your world today, but we had that at some point. Also challenge in scaling. Since the teams were still segregated at the LOB level, teams would still be, there would be no way we will be able to make a consistent approach to inner sourcing. Team would, let's say I find out that, hey, this XYZ LOB is writing a great pipeline in Fargate. I go and talk to their developer, and they're using altogether a different tool set with Chef, which requires a specific permission and specific number of licenses, and I can't be accommodated. So I cannot be inner sourcing. So it was just not a scalable model. So started looking at these challenges. We started converging our software for the pipeline. Said, okay, not everyone is going to have their own Jenkins. Let's have a single team in the company manage your CI/CD platform and use the consistent standard. Use Groovy libraries powered by JPL or Jenkins pipeline libraries back in the day. We also standardized our SDLC governance model. We said, okay, let's find out a standard way of releasing software. Standardize how do we do canary across your deployments, how do we do blue-green across your deployment, how do we find a specific branching strategy for the whole company, how do we find out specific OSS tools or vulnerability management tools across the company and speak the same language. Let's even build a single Sonar profile for specific language that your team use. So if you use Java, let's find out these quality gates which are applied across the board. Now you can go and write your own profile on top of that, but we want everyone to specify this one. We want you to meet a specific set of code coverage. So things of that nature were standardized across the company. And the last one, which kind of, the first two fueled into this one. So since we were now maintaining common standards across the board, we were able to much effectively inner source across the board, right? So we had a single backlog. We tried to create a single backlog. We made it a community-driven backlog where we had a single dashboard which said, hey, these are the features which are coming in. Which one do you want? The developers across the company started to go and say, hey, I like this pipeline is the top priority, and we picked up the one which had the most demand across the company. And it also brought in a lot of inner sourcing from different developers, collaborated on a single GitHub Jira ticket, or we also rewarded our developers through several means, and that fueled the we had a very small team from a central team capability, but because of this inner sourcing mindset and culture, we were able to scale much faster across the board. So as we were able to solve these 3 challenges or 3 problem statements, we made another big decision. A few years ago we said, okay, now those 3 challenges are resolved, let's start to converge as one single pipeline. And with that, we were able to create a single CI/CD flow across the board. Now it may seem like a very simple one. Sandy will talk about some of the stages that we added, but at a higher level, the CI/CD stages remain the same. You build your app, you test your app, you deploy it in different environments. We identified some of the things which some of these stages are kind of mandatory for you. Some of these have a lot of flexibility to still make you innovate at your job, and a lot of things are done behind the scenes which you don't have to reinvent the wheel across the board. Things which could be standardized, we did the standardization. We came up with standard model to deploy your application. So for example, the Fargate is the common use case across the company. We created a Fargate pattern. If you have Lambda serverless deployment, we created a Lambda serverless deployment. We standardized on our databases, and we created deployment model for those databases. And all of those were hosted in a repository and offered by the pipeline in a compliant manner. Now, because of these single pipeline or a single highway, as we call it internally, we were able to fuel the innovation on that very effectively. So for example, we support mono repositories, or we support poly repositories based on whichever your team has is more comfortable with. You can just choose that as well. So pipeline composability is another function that we recently introduced. By that I mean you can, like the deployment patterns that I mentioned earlier about Fargate, Lambda, EC2 base or any other service, we provided the capability of composing those patterns together, and so that you can deploy a large monorepo and you can have a holistic deployment instead of creating releasing 20 repositories in an orchestrated fashion. You can have one deployment which deploy your whole app holistically. IAC tools, we actually talked about reInvent, AWS reInvent last year on this. We selected AWS CDK and OpenTofu for your IAC deployments. To give you an example, through IAC we were able to, AWS released a feature last year for increasing the CloudFormation speed by 40%, and we got that without investing anything, because we were our backbone was using standard models or standard tools for deployments. Parallelization and intelligent builds. So we invested heavily on parallelizing your builds, right, using Jenkins features. We also introduced a feature called intelligent build. So for example, if your pipeline has gone up to 5 stages and it failed at the 5th stage, so and you want to go back and fix your code to re-trigger your pipeline, you don't have to run those 5 stages again. It should be able to skip 4 of those and should be able to save you hours. Similarly, we offered the features such as parallel deployment feature. So if you have 20 dev regions or 5 QA regions, you should be able to deploy in them parallel if you see that, if that's the need that you want, and even across regions. Pipeline analytics. This is something which is generally ignored by a lot of companies. We invested a lot on our analytics tools as well. So basically, as the pipeline is running, we are sending large events behind the scenes to our data lake, and we are making data-driven decisions almost every day. So we look at our databases. We say, hey, this stage used to take 5 minutes. It's taking 7 minutes. What could be the reason? Let's go and look at our Jenkins logs. Oh, there is a node wait time of that Jenkins log has increased. So let's go and tune that, and so that we are constantly comparing our the pipeline build time, deployment time, finding opportunities, which error code is occurring the most. We invested heavily in going detailed in our error code and finding specific error code for specific problem, and run analytics on that. And yeah, we also found out a way to push a lot of upgrades under the hood, right? So a lot of security upgrades that we push within the company through the pipelines generally are eventless. There is still a long way to go for us to find out to just completely take it off from our developers, where they don't have to worry about infrastructure, pushing vulnerability packages. That's our destination, but we have definitely made significant strides. With that, I'll pass it on to Sandy, who's going to cover the next steps.
Thank you, Ishu. That was an amazing journey on the pure CI/CD engineering side. I'm going to talk about the other half, where we partnered with our SDLC risk and cyber teams to build the policies and implement an enforcement to keep Capital One customers safe. Now, we started with this standard pipeline that Ishu talked about. This is a much simpler version than what he showed. And we made a couple of changes. So the first change was that we introduced a new stage for DevOps registry. So this allowed our engineers to register their new component that just came in with a new repository or an existing repository and identify the team that they belong to. This helped in two ways. The first one was that, and you all probably have experienced this already, a developer comes in, writes their code, checks in, then nothing happens. Then they figure out, oh, I forgot that Jenkins webhook. They then go and create that, and it starts the build. Then it again fails because there was no unit testing done. Or then they go, oh, yeah, I need to now go and link it with my SonarQube, all the cyber tools, and so on. So they had to, a new developer especially, they had to come and learn all the stages that should have happened behind the scene. Now, with this registration, we made this a one-click thing so that everyone could come in, create a new repository, create a new component, select their teams, and boom, behind the scene, everything is onboarded automatically for them. So that was the engineering side of the ease of use part. The other part was that when we allowed the engineer to create their component, a new component in CMDB, and have a repository linked to that and their team, now our compliance folks got the complete picture. Now, we could always find out from the repo who created it, which org it belongs to. We have CMDB, which identifies all the executives for the new component. But now we have everything together in one place in the DevOps registry. Now, we added the second part, the second stage, we call it the release readiness check. And this happened right before the deployment, the actual release to production. So like Ishu explained that everything, all the parallelization and intelligent build, everything that happens in parallel, we are actually collecting the data from all these various tools. So these tools are always streaming data. And behind the scene, a release decision is being made by the decisioning tool. Now, how it works is that these tools are all, some of them are SaaS tools, some of them are installed within Capital One. And these tools are sending data to a single location. We call it a collector. And that collects all the data. And when there is enough points are available, we make a decision and make it ready when actually the build reaches the approval stage. Now, there are two parts to it. A build could fail much before releasing, much before to the release state, right? If there is a problem somewhere in the configuration early, it would fail even before it goes to the release state. But if it goes to the release state, there are again two possibilities. We could find that, hey, a mandatory testing has failed, or there is a critical vulnerability, and we would cancel the release. The tool would cancel the release right away. But it will have all the information available for the team to analyze and understand why this release failed and what action they need to take. If the release had not been canceled, let's say there are no major deviations, the developer would then come there along with the tech lead or the product manager, and they could approve the release. And if they approve the release, it will go on and deploy into production, and everything is great. Now, what we found out, and we thought that our job was done, everything is working as expected, and great. Well, our developers were not happy because many releases failed because of some misconfigurations along the line, or a tool probably found a vulnerability at the very late stage, and that caused the release to be canceled. So their ask was, hey, instead of waiting for 25 minutes to find out that this release would not go through, couldn't you tell us within first 2, 3, 5 minutes that there is a problem? So we again went back to the drawing board, and we built a tool that we call shift left. Well, they asked to shift all the feedback to the left as much as possible, and we did. So when the pipeline starts, right before the build starts, we verify the configuration. And we not only look at the non-prod side, we also look at production. And we give the users an option that, do you want to proceed even if there are problems with production? Sometimes developers, they just want to build something and see in that non-prod region how it works. So for them, we don't want to stop them. They can go ahead. Sometimes they actually want to release it all the way to production, and let's say there is an AWS account, a typo there, or a security group does not exist anymore, or there is any problem in the configuration. So instead of failing right before the deployment, we started validating everything upfront, and within first couple of minutes, few minutes, we would actually fail if there are anything there. So now all the tools are not actually shifted left here. We have shifted left only what we could at this point. For example, any AWS configuration, we do that. We have more than 3,000 validations that we do in the shift left side today. And we have some integrations with the CI/CD and the cyber tools as much as possible there. Now, there are some things like the testing tools, for example. So these tools, so this testing stage comes at the very late, after the non-prod deployment has happened, and we have actually done the component testing and live dependency testing. So these test results are not available at build time. So those will still happen at the approval side, on the approval side, because the data is not available. But whatever we could, and I shouldn't say whatever, we are still in our journey. We have moved 3,000 validations upfront, but then there are more to do. But this actually has been very, very successful in reducing the production release failures in Capital One. Tomorrow, there is another talk. One of our colleagues going to talk about how we can shift this further left. So this is still after a pipeline starts a build. Can we make this happen on the desktop side? And that's what our colleague is going to talk about. All right. So we talked about shift left. That was one of our major learnings. But if I had to pick one thing for this entire thing to be successful, or what made it successful, would be standardization. Now think about 15,000 developers, 5,000 teams, 10 plus lines of business, working towards different goals to cater to their customers, which are again different in many cases. And they couldn't agree on one single thing. So the standardization was extremely important for us to figure out, to understand what are the various use cases that every line of business has, and how do we enable it. So today, we have this in a process where a developer, when they say, I want to create component X, they could select what type of application I'm going to build. Maybe it's a serverless Lambda REST API. And this process would actually create a hello world program, an API in this case, and deploy it to a development server, giving them everything to start working on their actual business problem. So that was the standardization part. The next was the scalability. As standardization happened, and we got 15,000 engineers to actually use, how am I doing on time? Okay, perfect. On using this system, we found there are many, many, many gaps. Now, when we had hundreds of pipelines, a team had their own pipeline. They exactly knew what they needed, and it was scaling perfect. When we brought it down to about 10 pipelines or so, we still had about 1,000, 1,500 engineers. There were problems, but it still worked. But then when we expanded this to everyone, 15,000 developers are coming in, and they are actually raising peers left and right. This became a major, major issue. We had to scale out our Jenkins nodes. We had to figure out how we could reuse. We implemented many, many things, and shift left actually helped there because the build would fail much before if there is a configuration problem, instead of continuing until it fails. So that also saved some resources, but all this helped there. There is another part that heavily helped on the scalability side was inner sourcing. Now, inner sourcing, there are two aspects here. So the first one was we had a very small core team that was working on our central pipeline that we call One Pipeline. And as Ishu mentioned, the team had a huge backlog, and they were not able to deliver at the speed that our lines of business, our partners actually wanted, so that they could actually use one pipeline. And inner sourcing is where everything kind of came in together. So we realized that this team is not going to be able to deliver everything probably in multiple years. So we made our code fully available to everyone to contribute. We had proper documentation so that our developers that are outside the core team would know how to develop, how to build, and how to make a release, and how to test and release. So that went a long way. And then there are also challenges, like they would raise a PR, and the PR would not be actually reviewed for sometimes weeks, because the core team was focused on building the features that they had in their hand. So we again went back to the board. We had to figure out how to expedite this, because imagine a developer. I just made 3 lines because this new feature is critical to my business, but then no one is looking at it for weeks. What motivation do I have to make another or contribute another PR here? So we had to go back to the board. We had to figure out how we'll do this. So we allocated time for our team's core team to look at all the PRs, come up with an SLA of just a couple of days so that every PR gets reviewed and merged, or given comments if the PR is not up to the standard. And then they will take ownership of the PR to test and release it to production. Again, the test is mostly automated. So this has immensely helped. And today we have about 40 plus different patterns, templates, that we call internally pipeline flavors, that support the standardization part for all the lines of business. And this couldn't have happened without the inner sourcing from 15,000 developers versus probably about 50 core engineers. We talked about shift left, but there is always more that we can shift left. So this has been a journey for us, and it will continue for some time. While we have shifted left, that we thought we shifted left whatever we could, we have again found many opportunities, and new ideas have come out from our various hackathons that we do in our team to bring further to the left. And then tomorrow we're going to learn more about how we can take this shift left completely out of our pipeline on the desktop side. And last but not the least, self-service. The entire platform that we designed for several years now have always been focused on how we can make it self-serviceable. The engineer should come in and figure out what they need to do to get themselves going. And over the years, we have built many, many features to make their lives easy. Now, one part that we have seen once the scalability happened and we actually allowed all 15,000 developers to use our platform, we found that there are mistakes they make in their configuration that we are providing them with messages that are not very clear. Some of them are pretty straightforward, like there is a mistype in that in the account number, for example. We give them enough information saying that, hey, this X account does not exist. So they know what to fix, they can go and do that. But there are complex situations. Sometimes a combination of AWS services, they don't work together very well. And the configurations are missing. And another example could be on the compliance side. For example, every AWS resource that we provision has to be tagged with the application and the component name. Again, these are not AWS requirements. These are Capital One requirements. And the build fails. So they have to sometimes kind of wonder, what tag did I miss and where? So it's been a journey for us to make sure that our error messages are clear enough for someone who is not part of the core team. And I don't want to say we are there yet. We still have errors that are still pretty cryptic at runtime, and we are trying to figure out how we can make this easy. In our destination state, which we hope to reach in another couple of quarters, where we should not need any support engineers. So all our support engineers can focus on building new functionality. And our messages would be so clear that an engineer can just look at the message, maybe it can point to a documentation if it's a complex one, and they read it, they understand exactly what to do, and make the changes. So I went over fairly quickly. If there are any questions, we can take those, but thank you again for your time.
do we take questions here, or if you have any, me and Sandy will be here for next 1 hour in the hallway, or just grab us if you need. Perfect.
All right. Thank you.
Thank you all.